Hey everyone, we are now going to begin talking about chapter 2. So this is the chapter 2, oops, in the wrong spot. This is the chapter 2 lecture video for Chemistry and Society, Chem 1115. And again, as I mentioned in the chapter 1 video, this video makes reference to other full lectures that I have already recorded. Those are lectures that are from live class presentations in front of real students. So those are full-length lecture videos that I make reference to in this notes packet that you need to either go to my YouTube channel and watch or go out onto Canvas and watch. Because I'm not going to spend time in the notes going over things that I already have a full lecture on. So just please, please, please make time to go watch the videos that I reference in this notes guide. All right, so chapter 2 is about the air we breathe. And here are some guiding questions to help get us started. Things like what's in the air that we're breathing, what are the impurities in the air that we're breathing and how they got there, and how does that affect us as living things. And so this is actually a reflection that you're going to be doing, so I am not going to give you any answers here. Now, this is kind of a nonsense question because everybody knows that breathing is important, right? We breathe so that we can stay alive. And so if you are interested, you can actually kind of calculate how much air you go through in a typical day. And you can measure how many breaths you take in a minute and then multiply that by the number of minutes in an hour and the number of hours in a day. You can get a general idea of your resting volume. Now, of course, if you go for a run or you go to the gym, obviously you're going to be breathing much more than if you're just sitting. But this gives you an idea of, wow, you know, I'm a living thing and I take in a lot of air every day. And so air should be pretty important to you. If you hadn't thought of that before, now is a good time to think about that. So air is, the air that we breathe at least, is found in the troposphere, which is the lowest layer of the atmosphere, right? So we're down here, the troposphere is what's near the ground. That's what we're breathing. The ozone layer is found in the stratosphere, and then you've got the mesosphere, the thermosphere, and the exosphere. Obviously, you're not hanging out up here because there's a satellite. That's where satellites orbit. So that's way up high. Okay, so we're breathing air down here in the troposphere, and the composition of each one of these layers is different. Okay, so don't think that the composition down here in the troposphere is the same as up here in the thermosphere, for instance. It's very different, very, very different. So last chapter, in chapter 1, we learned about mixtures. We also learned more about mixtures when we watched the classifying matter video, right? So air is a mixture, it's a physical combination, and it is actually what we would call a heterogeneous mixture because it does have some variation in composition. It's not exactly the same breakdown. So we would call it a heterogeneous mixture. And so when we breathe air, inhaled air, we're breathing primarily nitrogen gas. That's fine, it's not going to hurt us unless nitrogen was the only thing you were breathing. It's no big deal because you breathe it in and look, you exhale it right out. It's not interesting to us as living things. So you breathe it in, spit it back out. Oxygen, this is how much we take in, there's what we breathe back out. That's good because if you took 100% of the oxygen, we would have no oxygen left. Argon, not interesting to us as living things. We spit it out. Now, anyone, obviously this isn't a lecture class, but can you think about why we exhale more carbon dioxide than we breathe in? Think about that for a second. If you come up with the answer, it's probably because you took biology recently, right? Living things as a waste product produce carbon dioxide. So one of the things that happens when our cells break down food is that we produce CO2. That CO2 is exhaled as we breathe. So we're only taking in a small amount of carbon dioxide, but we're exhaling, each breath is 4% carbon dioxide. Where's that coming from? It's not coming because we inhaled it, it's coming as waste product from us, from our cellular metabolism. And then the water composition varies based on humidity, right? If you're in a really humid room versus a really dry place, that water vapor will vary by your location. So other things that we breathe would be pollution. So these are pictures of smog from 2 different days. So obviously anything that's in the air, that's pollution, you're breathing it in too. And one of the other things that can happen is that cooler air, like in a valley, can get trapped, retain pollution. So pollution is not the same, obviously, throughout the world. It's not the same throughout even the same state. It's all based on the topography of the land. So when we talk about molecules, we talk about them in 3 different ways. We talk about macroscopic, which means what we can see, the things that we can visually see with our eyes. We talk about the symbolic, that's when we use symbols to write formulas like we did in chapter 1. And then we talk about the particulate, which is what it looks like if we could draw a picture of the atoms. And molecular structures are just a way to represent that. You'll see these little cartoons throughout your book, and it gives you a key right here of what colors. Okay, so this is a carbon atom in the middle. That's carbon atom in the middle, and then it's got 2 oxygens. So that is carbon dioxide. Now, this is something that you're going to have to learn. You're going to have to memorize it. So make a note to yourself. You need to memorize this chart of prefixes. 1 means mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Because when we name molecular compounds, we use what's called the prefix system. The prefix system has its own lecture. So go out onto Canvas or to the YouTube channel and watch the video called Naming Covalent Molecules. I'm not going to spend time in this notes guide going over it because I have a full lecture about it. And so why repeat something that has already been done, right? So I'm just going to warn you that naming molecular compounds will be on the chapter 2 quiz, and it will be on exam 1. So after you watch this notes guide, go out onto the YouTube channel or to Canvas and watch my video that I have on naming covalent molecules using the prefix system. But here's just kind of a summary of what you do. You look at the formula and it tells you how many are there, right? So 2 means di, and then you use your periodic table. N stands for nitrogen. So it would be dinitrogen. And then 5 means pent from your prefix chart. And this is, use your periodic table. O means oxygen. So this is dinitrogen pentoxide. Again, I have a video on the YouTube channel and on Canvas. It's the same video going over in detail how to name molecular compounds. And it is something that is fair game for the chapter 2 quiz, and it's something that's fair game for exam 1, which means you're going to see it. So please take the time to go watch that. Now, if the first element, there's only 1, you don't have to put mon. So it's not called monocarbon monoxide, it's just called carbon monoxide. So here are some for you to try on your own. Just pause the video and give it a try. And then sometimes we don't use the molecular name, we use a common name. So dihydrogen monoxide, have you thought about what that might be? Hydrogen 2, O1, that's H2O. So the actual real name of of water is dihydrogen monoxide. You can be a real smarty sometime and ask your friend, hey, would you mind getting me a glass of dihydrogen monoxide? And they'll be like, what? Nitrogen trihydride, nitrogen in H3, the common name would be ammonia. And then trioxygen O3, that is ozone. All right, now some of these are ones you're familiar with. They're called the dangerous few in your book. These are ones that you should be exposed to through your studies in other classes. Carbon monoxide is probably something you've heard of. It is a colorless, odorless gas. And if you have a furnace in your home, you need to make sure you have a carbon monoxide detector because it is called the silent killer. It binds to the hemoglobin in your blood better than oxygen does. And so if you have carbon monoxide in your home, you can actually die of asphyxiation pretty easily. So if you don't have one already, please go out and buy a carbon monoxide detector, invest in your family's safety. Ozone is something we're going to talk about a lot in this class. It's not great for your lungs. Sulfur dioxide, this dissolves in water to form acids, and it also is a component of acid rain. And then the same thing with nitrogen oxides. They can dissolve in liquid and water to form acids, and also are components of acid rain. Then lead, that's not a compound, that's an element, right? But lead is really nasty stuff, and you don't want anything to do with any lead. And then particulate matter, PM, as your book calls it, this can just be any sort of debris, right? So this could be, even just like your dusts and your dirts and that sort of thing, but it's tiny solid particles and microscopic droplets. And so when if you're working for an environmental protection agency type organization, you would look at three things when you're assessing how risky an air pollutant is. You look at the data to see the toxicity and the exposure. So in other words, how toxic is the substance? And then how much of the substance were you exposed to? So here's some data from your textbook on concentration of different pollutants in the air, and I'll just let you read that over on your own. It's also in your textbook. And here are some air quality data for differing cities throughout the United States. Again, this is something you can just kind of look at over your leisure. And this is a problem that you can think about on your own. Just pause the video and think about it. So the air quality index, if you ever go check the weather, a lot of times the weather will tell you, if you're looking at, the high today is going to be 97 and the air quality index color is green, right? That comes from this. This is a standardized table called the air quality index, the AQI. And so if it's green, that means that the range is the 0 to 50. And then anything above that, we consider moderate, et cetera, et cetera, et cetera. So if you're looking at your air quality index for your town, usually it's reported on your weather. So just for fun, go check your weather right now and see what your air quality index is today. Here's an example of one. And here's a picture. A lot of times it shows it over differing times of the day. So this figure was showing it Friday, Saturday, Sunday, Monday, Tuesday. So as the weather changes, the air quality index changes along with it. Okay, changing gears for a minute, we need to talk about what a chemical reaction is. A chemical reaction occurs when reactants, and that's the substance you begin with, are converted into products, and those are the substance that you end with. So you usually have something, and then an arrow, and then something else. So A and B are my reactants here, and C and D are my products. And I have a video on my YouTube channel. If I don't have an advertisement for it in here. Yes, I do. Okay. Go out onto my YouTube channel or Canvas page and watch the video on balancing equations, because I have a full lecture about balancing equations. This is a very important topic. You're going to see it on the Chapter 2 quiz. You're going to see it on exam 1. So go out there, spend the time, watch the lecture video, and then it's going to take some practice to get good at this. So I have some practice problems that I have posted on Canvas as well. The answer keys are included. All right, so here are the general tips for balancing an equation. If you have one element on each side, those are the easiest ones to do, so do them first. And then anything that is in more than one substance, do them last. And again, this is something that you can read over on your own. I'm not going to spend time in this notes lecture going over it because I have a full lecture. I think it's a 50-some minute lecture on balancing equations. All right, let's get back to our environmental chemistry kind of stuff. Those of us who drive, which is pretty much everybody, we produce vehicle emissions, and that comes from the exhaust. And so you can take a look at this. And the particulate emissions, again, that's the debris and stuff in the air. So some sources of sulfur in the air, sulfur in coal, when it's burned and that sort of thing. Sources of nitrogen oxides in the air, it reacts with other substances. And then in your car, you have something called a catalytic converter that's there to reduce the amount of carbon monoxide, which is good. And then there's a nice little video link here that you can go check out and watch that. Now, a primary pollutant and a secondary pollutant. Ozone's considered a secondary pollutant because it comes from reactions with primary pollutants. So for instance, in this example, nitrogen dioxide would be the primary pollutant, and then it reacts and produces this reaction down here that gives me the ozone. So the primary pollutant makes a secondary pollutant. So again, here's that same graphic from a little while ago. Well, same part of the country, I should say. And it's looking at ozone levels and how they change throughout the day. And so that's where we are going to stop for for chapter 2. Again, in this lecture, I made reference to 2 videos that you need to go watch on your own. You need to go watch balancing equations on your own, and you need to go watch naming molecular compounds on your own, because both of those are going to be on the chapter 2 quiz, and they're both going to be on exam 1. And if you have any questions, please don't hesitate to reach out. And I hope you have a great day, and I will see you next time. Bye.